Solutions for the mock exam for integration. Number 1. Here's a table similar to those tables they sometimes give us for differentiation problems. In fact, it is a differentiation table. So we have two functions. We have the f function, we have the g function. We have the derivative of the f function, some values given, depending on the x values 1, 2, 3, and 4. And we have the derivative of the g function, also some values given for the x values 1, 2, 3, and 4. Let's go down and see what they want. Calculate the following. The derivative of f plus g when x equals 4. Okay. Well, we don't know what the function f plus g is. We don't even know what the function f or g is. But we do know that when you take the derivative of two things added together, it's the same thing as taking the derivative of them separately. So we do know that it's equal to that. And then we just need to evaluate it at x equals 4. So we do know that the derivative of f is f dashed. And we do know that the derivative of g is g dashed. And we wanted to evaluate it at x equals 4. X equals 4, the value for f dashed at x equals 4 is 7. The derivative of g dashed at x equals 4 is 4. So we know that this one is going to be 7. And we know that this one is going to be 4. So the answer is going to be 11. Okay, that wasn't so bad, was it? Now, we come down here and it asks us, what is the integral of g dashed plus 6 evaluated from the limits 1 to 3? So, we also know that when you take the integral of two things added together like that, it's the same thing as taking the integral of the first thing plus the integral of the second thing. This makes it a little bit easier for us. The integral of g dashed, of course, is g. And we just need to evaluate it from x equals 1 to x equals 3. The integral of 6 is 6x, of course. We just need to evaluate it from the limits 1 to 3. The way we do that, of course, is we just take g of 3 minus g of 1 plus 6 times 3 minus 6 times 1. This is going to be 18 minus 6, which is 12. g3, if we look up here, g when x equals 3 is 2. So we'll put here 2. g of 1, g when x equals 1 is 1. So now we can put here 1. So we have 2 minus 1 plus 12, which is equal to 1 plus 12, which is 13. Okay. Number 2. The function f is such that the second derivative of f is 2x minus 2. When the graph of f is drawn, it has a minimum point at 3, negative 7. Show that the first derivative of f is x squared minus 2x minus 3, hence find f of x. Okay, so if we know that the second derivative is 2x minus 2, well, the first derivative would be the anti-derivative of that, which would just be, we would take 2x minus 2 and we would take the integral of that. We'd say that would be 2x squared divided by 2 minus 2x plus c. Right? That's the integral. Once we find that, we know that that's equal to the first derivative of the function because this was the second derivative. Okay. Now that we have the first derivative, it says that we know that at the point 3 comma negative 7, there is a minimum point. Remember that when you have a minimum point or a critical point, that means that the first derivative of the function is going to be 0. So what that's saying is, at x equals 3, the first derivative is equal to 0. How do we express that? We could say f dash of 3 equals 0. And then we're going to substitute in 3 for all the x's here. So it's going to be 2, 3 squared divided by 2 minus 2 times 3 plus c. And then if we work out the arithmetic here, it's 2 times 3, which is 18, divided by 2, which is 9. So it's 9 minus 6 plus c is equal to 0. So that's equal to 0 equals 3 plus c. c is equal to negative 3. So we could rewrite our this is f dash here. We could write our f dash function as x squared minus 2x minus 3. And hey, that's what we're expecting to get. Okay? And now we're going to find f of x. And so f of x is just going to be the integral of that. So the integral of that would be x cubed over 3 minus x squared divided by 2 times 2, so it's just x squared, and then minus 3x plus c. Now, they gave us enough information here. They gave us a point that f of 3 is equal to negative 7. So we can actually figure out what c is here, too. We could put in f of 3, and then we know that that's equal to negative 7. So, let's see. X equals to 7. 3 cubed divided by 3 minus 3 squared minus 3 times 3, which is also 3 squared, plus c equals negative 7. And we know that these, so that would be 3 squared divided by 3 is also 3 squared. So we have 3 squared minus 3 squared minus 3 squared. These cancel out, so we have minus 3 squared plus c equals negative 7. Negative 9 plus c equals negative 7. So we have, and then we add 9 to both sides, and that will give us c is equal to positive 2. So our f function, f of x, we can rewrite it as x cubed divided by 3 minus x squared minus 3x and plus 2 would be the c value. Okay, let's go on to b. It gives us some specific values of x equals 0, x equals negative 1, and it wants to find the values of f of x and f dash of x when those x values are taken on. So let's take f of 0 first. So f of 0 means we're going to put 0 in for x in this function here. So it would be 0 minus 0 minus 0 plus 2. So the value would just be 2. Then we have f of negative 1. If we put negative 1 in the same function, we would have negative 1 cubed, which is negative 1 divided by 3, minus negative 1 squared, which is just 1, minus 3 times negative 1, which would be positive 3, plus 2. And that would give us 4 minus a negative 1/3, which is 3 2/3, which can also be rewritten as 11/3. Okay, and then the last thing is they want us to find the f dashed of negative 1. So what is the derivative, or what is the derivative of the function at the value of x equals negative 1? And then we just need to put negative 1 into the f dashed function, which is this function here. So we put in negative 1 in for x squared, so that gives us positive 1. We put negative 1 times negative 2, which is positive 2. And then we subtract 3, and then 1 plus 2 minus 3, of course, is 0. So f dashed at negative 1 is equal to 0, which means there's even we've just found a critical point of the function. It's either going to be a maximum or a minimum. Now, part C asks us to use the information we got in part B to graph the function. So first thing we're going to do is we're going to draw an x and y axis. and then we're gonna graph some of these points. For example, we got 0, 2. So let's graph 0, 2. 0, 2 is right there. Then we also have negative 1, 11 thirds, also known as 3 2/3. Negative 1 and 3 2/3, which would be about there. And then we also know that at x equals negative 1, the derivative is 0. So we know that at this point here, it's a maximum or a minimum. And judging from the fact that there is a point at 0, 2, I would say it's a maximum. Okay? And then last thing, they did give us an additional point here in part at the beginning. They said that one of the points is equal to 3, negative 7. So why don't we graph that point too? 3, negative 7. Not only did they give us 3, negative 7, but they told us that 3, negative 7 is a minimum. So we can also make that a minimum. Now we just connect everything. So it's going to look kind of like this, and kind of like this. Now notice it says it is not necessary to find the coordinates of the points where the graph cuts the x-axis. So you can see that there's a few points. There's 3 points where it cuts the x-axis, and those, we'd have to take derivative and solve for x, and it's not an easy thing to do, so thank goodness they said we do not need to know that. So the only thing you're really sure about are like, is this area here or this area here? You don't know exactly where it crosses between those, but that's okay because they didn't really ask for that. Okay? Now for the last one, number 3. So it says that they have an integral here, a definite integral. It's a definite integral because it goes from x equals 1 to x equals 5. You actually evaluate the integral as a number. You don't just write it as a function. And so it says that if you take 3 times this function and you take the integral and then you evaluate it at x equals 1 to x equals 5, you get 12. Okay. Then it asks you, what happens if instead of evaluating an integral from 1 through 5, you do 5 through 1, it makes it the opposite. And then also, instead of having the 3 times the f of x, you simply have the function f. So remember that if you have the function from 1 through 5, if you take the integral from 1 through 5, that is the same thing as taking the integral from 5 to 1 if you take the negative of that. Okay? So the fact that they're switching the 5 and the 1 here is just going to make it negative. Okay? And then if you have a function times a coefficient and you're taking the integral of it, that is simply equal to taking the 3 times the integral of the function. Okay? Because remember that, like when you take derivatives, when you take integrals of functions, if there's a coefficient in the front, you simply carry it to the next step. So that's exactly what you're going to do. So let's show how this here, the 12 becomes a negative 4 here. So the first thing you're going to do is you're going to say, okay, well this is just the same thing as if I would put the 3 out front, right? And then the next thing is, well, if I switch the 5 and the 1, that's the same thing as taking the negative of the integral. So I could take the negative integral if I put 5, 1. And I'm leaving out the dx's here, but actually there's dx after each step here. And then, so that's equal to negative 3 times 5, 1 f of x dx. Alright, and then I know that that's equal to 12, right? So now I can solve for this integral here by dividing both sides by negative 3, and then I will end up with negative 4, which is exactly what they asked us to show. Okay, now part B. Find the value of, and then it gives us this kind of crazy looking thing here. It's got 2 integrals added together. One of the integrals has a definite integral going from 1 to 2. The other one has a definite integral going from 2 to 5. And it's got the exact same thing inside. Now remember, if you have the remember the integral is like finding the area of a function. And let's say that you have a function that goes from like 1 through 5, just like this one. Okay? And then you got this area under here, and you want to calculate this area. Now, if you found the area from 1 to 2 first, and then you found the area from 2 to 5 second, and you just added them together, you're going to get the exact same purple area as before. So if you have this integral from 1 to 2 and an integral from 2 to 5, it's the same thing as taking the integral of 1 through 5. So it's 1 through 5 x plus f of x dx. Now, to find the integral of each of these, the integral of x is going to be x squared divided by 2. The integral of f of x is, we don't know what it is, but we'll just put here 1 through 5 f of x. Okay? And then the x squared over 2 is going to be evaluated from 1 through 5. So we're going to put 5 in there. We're going to evaluate this. So it's going to be 5 squared divided by 2 minus 1 squared divided by 2. Because first you put in this into the function itself, and then you subtract the function by putting 1 inside 2. So it'll be like this. 5 squared divided by 2 minus 1 squared divided by 2, which is just equal to 25 divided by 2 minus 1 over 2, which is going to be 24 divided by 2, which is 12. So this is going to be 12. And then we know that this integral here, the integral of 1 through 5 of f of x dx, we already have that. It's right up here. It was given to us. We know that the integral of 1 through 5 of f of x dx is actually 1/3 of 12, which is 4. So here we know this is going to be 4. It's going to be 16 is the answer. And I think that's it. Okay? Now it's obvious to you here that remember that this is equal to you can divide both sides. You can put the 3 outside the integral. So, and then you can divide both sides by 3. That'll be f of x dx is equal to 4. Right? That's where we got the 4. Okay? So that's it.